Hey, David.
Hey, Dami.
What's up? How have you been?
Good.
I haven't
Hold
seen.
on, I'm just trying to figure out how to start my video.
Oh yeah.
Here we go.
Yeah, I said I haven't seen you in 2 weeks. What's up? I've been up to. Did you hear me, David? Can you hear me, David?
Yeah, I can hear you.
Okay, I said, what have you been up to? I haven't seen you in 2 weeks.
Oh yeah, I've been doing the coding thing. Just in quarantine, trying to stay active. Been like running and whatnot. But not a whole lot. How about you?
Okay, all right. Okay, so Reina, what's up? How have you been, sir?
I've been pretty good. Just been doing a lot of schoolwork and stuff because my school year's not over yet.
All right. And how are you finding the whole thing? Like, how has it been for you?
Oh, it's been lots of fun. I really like it. I finished assignment 2 a couple days ago, and then I tried one of like the extra activities too because I was having lots of fun.
Has it been challenging?
Some of the things have been challenging, and then like one of the most challenging parts is like trying to find mistakes that I've made and like trying to fix those so that they work. But overall, I think like it's been like a good level of challenging, not too challenging, but also enough to push myself.
Okay, that's great. Like I'm happy to hear that. Safai, how are you?
Thanks. Good. Thanks. Good.
Yeah, how's it been too for you?
The exercises, you mean?
Yeah, I mean like the whole thing generally, the journey so far, your assignments and everything.
The assignments that were not so easy, but not very difficult for me. I could do everything. I think not everything, but only the essential things, and 2 more things in addition.
Okay. All right, so I mean that's great to hear from everybody. Andreas, what's up, man?
Hey.
Yeah.
How are you?
I'm okay. How about you?
Good, thanks. Got my second assignment done. Just got done, so all good.
Okay, that's cool. So I think we can start right away because of these 40 minutes time limit and stuff. So a couple of people are probably still going to join us, but we should just go on at least for now. Now let me share my screen so we can quickly start what we have to do. Okay, let me know when you can all see my screen. Can you see my screen?
Yeah.
Okay. So I'm trying to close this Android, whatever. I have my aunt's phone system. Okay, let's just go on there. So what we're going to be doing today, we are going to be looking at making use of functions with parameters and just applying our for loops or while loops again to very simple problems. So we're just going to recap on loops and functions with parameters. I believe we had a bit of video on functions with parameters during the week. Am I right? Okay. So I think we understand what functions with parameters mean. We've done quite a number of things on functions already. So we're going to be dealing with parameters this time around. Sorry, we have somebody I'm trying to admit. Okay. Yeah. Okay. So who am I gonna? I'm okay, Reina. Can you just give us a very, very quick description of what you understand by functions or parameters?
So you can have some inputs and some kind of returns, and when you have the parameters, it lets you provide a function with like some information before.
Oh yeah, exactly. So they're just basically regular functions, but then you're giving them some kind of information which they will be using to execute whatever you want them to do. So yeah, basically functions. I mean, you could always do things without parameters also, but it's just an easy way of passing your information to the functions. So I think we'll understand better once we try to solve some of all these problems we have. So we're going to be solving three simple problems. And okay, number one is called the dog years. So basically what this program does is you give an input of an age in human years, like probably some human is 20 years old. You put in their age and you say, okay, what's going to be the age in terms when you're looking at it from a dog lifespan perspective. And there's a constant which we know in this problem, which is that there are 7 dog years per human year. So basically, for every 1 year, let me say, human live, or how do I put this exactly? So there are 7 dog years per human year. So for every 1 year an human lives is equivalent to 7 dog years. Do we understand? Like okay, yeah. So I do not need to even complicate things because I think trying to break it down too much is making it a bit complicated. So there are 7 dog years per human year. And we're going to be taking in an input, which is the age of the human. And then we are going to be saying, okay, if this human is 1 year old, then this dog is going to be 7 years old, like looking at it from the human perspective. So that's basically what our program wants to do. It's kind of similar to what we did last time. That's the moon weight. We get the weight on Earth, and then we say, what's the weight on the moon? And then we simply multiply it by 0.165 to get the equivalence of the weight on Earth on the moon. So let's just do that very, very quickly here. So our dog years, first of all, we're always having this if name is equals to me. We know this is always in every one of our files. So what do we want to execute as this entry? The main function, which we do not have yet. That's why we have the function calling in red. So we create this main function. That's where we always want to execute our code from. So yeah, that's it. So what do we want to do in this function? We want to collect years in human years and then say this is going to be the equivalent in dog years. So what do we want to do? Let's try to break this thing down into functions and say this is going to be the main function. That's what's going to be called by the computer. But then we want to create a function that will be converting the human years into dog years. We could call that function, let's call it dog years. Let's just call it dog years. And then what do we want to pass into these dog years? Can someone just tell us what we want to pass into these dog years? We are going to be getting dog years based on the question we have here. Okay, so basically based on this question we have here, we want to calculate the dog years, and that's what we want this function to do for us, dog years. So we are going to be passing human years into it to get our equivalent dog years. And we're told that there are 7 dog years per human year. So if we want to get this dog year, we're going to be multiplying our human years by 7, right? And okay, once we do this, let's store it in a variable. Let's call it years. Let's just call it years. Since it's limited to this function, we can always know that that's what we want. But then this function just basically executes this. That's what takes us to return statements. We're just storing this result into the variable called years. There's nothing we're actually doing with this function. So if we call this function anywhere, it executes what is inside, stores this value into the variable years, but we do not have that variable outside this function. But what we want to do is to call this function from somewhere else. For example, we want to first of all collect the human years. Let's call it human years is equals to, we remember the function for collecting input from the user is called input, right? And then we say enter human years. We store it as human years. And we remember also that once we collect values from the user, it stores them as strings. Do we remember that also? It stores those values as strings. So what we want to do now is the variable casting, the variable casting, which will help us convert these human years to floats, and that is the value which we want to use in calculation, so that we can perform operations such as multiplication, additions, and the rest of them on it. So we're going to be doing human years equals to float. That's how to cast into a float, and then passing the value we collected from the user, that is human years. We are simply replacing the value, the variable in memory. So we say human years.
Use integer here?
Sorry? Okay.
Can we use integer instead of float?
Yeah, we can as well use integer, but you know, when we use integer, our fear is that when, for example, when I collect this variable and I put like the human year is about 7.5 years, and I put 7.5, by the time you convert into an integer throws away whatever value you have after the decimal place. You understand? So that drops our precision to a certain extent. So that's the reason, not like integer is not going to work, it's going to work, but you know, our precision is going to be a bit reduced. So using floats, and then we'll get the human years. So what we'll do now is to call and get, what we want to do right now is to get dog years. Like, what's going to be the, okay, let's rename this function so that we can use this function name as a variable in our main function also. Dog years from human. Okay, let's call it human years to dog years. Do we get what I'm trying to do? So I'm just changing the name of the function. So in this function, we can call dog years. Let's just store dog years and call this human years to dog years. Human years to dog years. What do we want to pass into this human years to dog years is the human years, because that's what the function uses. That's the dependency of this function. The function for it to get the dog years, it depends on the human years you pass into it, right? So before it can calculate the dog years, it needs to have human years in hand. So it's just like basic mathematics. Like before you can calculate on the square of the value, you need to have the value. But you yourself know how to calculate the square of the value. That's what this function does. This function knows how to convert human years to dog years, but it needs the value to be passed in for it to be able to do anything at all. So we pass in the human years. All right.
I have another question. Can we only write return years?
Yes, exactly. So we are coming here. So we could do a return years right here.
Yes, and near the dog years.
Sorry?
We can write near the dog years.
Yeah.
In main part.
Mm-hmm.
We can write human years to dog years, and only years, not human years in club. Was in brackets.
So are you talking about the variable name?
Mm-hmm.
So like years this way, right?
No.
I think what she means. I think you meant passing years instead of human years to the function called human years to dog years, right?
No, not there.
Yeah.
Not there.
I think when you call the function in line 4.
Oh,
no,
line
in main.
4. Okay, yeah.
No, in main part, yeah. There.
So call it what?
Years.
Yes. So, but we do not have years variable right here. So we have to, that means if we make these years, we have to make our value here, maybe years. Do you understand? This is not.
But this value is not the same within the human years to dog years definition part.
Yeah. Oh, okay. It is.
Yeah, this is different from the first years in main part.
Yeah, because okay, you know what? Let's just make it like completely distinct. Right now, you know, it won't really matter because this years is limited to this function. It's in this function block.
Yes.
So it doesn't actually affect wherever you use it again in other functions. So we could just make it maybe distinct. I understand you now. So human years inputs, let's call it human years inputs, and then store it as human years inputs. So what we want to do is we want to send in human years inputs into this function called human years to dog years. So we could just say human years equals to human years inputs. Are we getting that? So we could as well just pass in human years input without stating this, but just for clarity's sake, what we want here is to for this function to take our human years input as its own human years. You understand, right?
Yes. Yeah.
Okay. I mean, do you all understand?
No.
What's the in the function call again in line 4 now? What does that mean? Human years equals human years input.
Years input. Yeah.
Exactly. So that's what I'm saying. Like for clarity's sake, I just did. You know, in this function, our human years input, we called it also here, right?
Mm-hmm.
We called it here. So if we call it here, what we want to do is to tell this function, hey, human years for you is going to be equal to our own human years input.
So you basically just made it explicit. It's the same thing as just putting human years input, but that makes it more explicit, but has the same meaning.
Exactly. So it's just to make it more explicit, just to, okay, this for you is equal to this for us. So now we have our dog years right here. And that's going to be floats, remember, because everything we've been performing our operations with have always been floats. We could also make this a float too, but it's not really going to matter. Once you perform operation with floats and integers, you still get a float anyways. So what we want to do right here is now to print dog years equals to let's just dash dog yes. So because we have that as a float, we would want to convert it into a string by wrapping it into a string function called str. Yeah, I think we do understand this part. We remember this part, right? Wrapping it in the function str. So let's try to run our program now and just say python dog yes .py. Oh, okay, it's in a different folder. Sorry guys, I'm still here. The power went out. Just give me 1 minute. Hey guys, sorry for the interruption. So let's just run our program and then say python dog yes. Sorry, this is equals to name if name equals to main. So enter human years, and so what we want to convert now is 100 human years. So it's going to be equivalent to 700 dog years. I believe we understand what we did with this program. But does anybody have a question? Okay, so we need to move really fast. So our next problem right now is running total. So what this program does is it asks a user to continuously enter numbers and it prints out the running total so far. Once you get the program working, see if you can modify it so that the program stops when the user enters a 0. So do we understand this concept, or do I explain it better? Do we all understand? From this screen,
Maybe you should explain.
okay, from this screenshot, what the program would do is a program would keep on, or let's say continuously. I mean, from this continuously, we already understand that this problem is going to be a loop problem. Do you get that, right? So if you keep on entering those values, it keeps accumulating the sum of those values. So if it asks me for the value once 7, then it tells me our total is still 7 because we have only one number. Then it asks me again, enter a value is 3. It's was it sums it to the previous one, making 10. Then it says enter a value again, 5. It sums it to the previous one, making 15. If I enter 5 again here, it sums it with this, then it tells me my running total is 20. So, you know, just on and on and on and on like that. So we are going to be doing this in a loop apparently, since we have to continuously take those values. So we can come back to this final part of the problem, which says the program should stop when the user enters a 0. So what we want to do right now is,
while input is not equal to 0,
yeah, no,
asking.
yeah, exactly. As long as the input is not equal to 0, continue asking. So what do we want to do here, right? We can run everything in our main function, since we already understand the concept of functions with parameters. So I mean, we are really in a rush, and I really do not like the way we're rushing. But anyways, let's continue. So what we want to do right now is to first of all collect the value from the user, isn't it? Or what do you guys think? What do you guys think? I mean, if this is the only problem, if we can't get to the third problem, I believe understanding this very well is quite important also. So What do you guys? What do we think? What do you think is going to be the first thing to do here?
So you'll probably need a variable to keep track of the sum
Okay.
of the numbers that the user has entered so far, and then you need to
So
yeah,
let's
could be
let's
sum.
call,
You
let's call
initialize.
that something.
Yeah, could be sum or running number or running sum or whatever. I don't know.
Running sum, and then what do we initialize that to?
Would initialize it to 0,
Okay.
and
So
then you need to collect user input.
okay. So what do we? Let's call that user input the number, and then say input.
Enter a number.
Enter a number. So what do we have to do next?
We
Anybody?
add the number to the running sum, or what? To get the first output, right?
Okay.
Because I don't know how we're going to get the first output here if we don't do that.
Okay, so once we add the number to the running sum, we store it as running sum, right?
This number here.
Okay. So
The problem is number is a string now,
exactly.
not a
So,
float. And
right, that's a good catch. We're forgetting that we have to cast that into a float. Let's use a float. Or
yeah.
use an integer or something. Float is also.
What if the user enters a float? Then we are limited, right?
Yeah, exactly. So that's why we want to use float. So what else do
And
you think? Okay.
you will probably now need some sort of loop around the after initializing that variable running sum. After that, you will need a loop, I think.
Okay.
Oh.
So do we all agree, David, Reina,
Wouldn't you want to print that like the running total is, and then print what the running sum is before you
Okay.
loop it?
Good point. That's missing. Yeah.
Yeah.
So
Okay.
Yeah.
the running
Number.
sum, then we add the running sum in
Running sum.
as a string, right?
Yeah.
Okay, so next thing.
We have to make a loop now.
Okay,
right?
So yeah, we'll make a loop like Andrea said. And so where is the loop going to be? I mean, what lines are going to be in the block of the loop?
Number
3, 4, 5.
3, 4. Yeah, 3, 4.
Okay. So
before.
Yeah.
So what kind of loop do we use, and what kind of statements do we have in our loop line?
Indefinite loop, a while loop, right?
Yeah, right. So so we use the while true. Okay.
Okay.
Whatever is not 0 or whatever is not false, we could just make it a while loop, like while true or something. So
I didn't get that.
whatever is not 0 or whatever is not false, we could put that as the value we pass after the while. So we could also say while 1. That would also work because 1 is always going to evaluate to true. Do you understand?
And what was the, so if the user enters 0, then the program stops. Was that it?
Yeah, exactly. We haven't done that right now. This works indefinitely.
Okay. No.
So
then you will have to evaluate number. You will need, I think, an if statement too. Then still, right?
Okay.
If number is equals 0, we can write break.
Correct. So that's pretty much everything we're supposed to do with this program. We instantiate our running sum equals to 0. Then we do, and also, you know, even we could do this some, okay, but then let's run this program first, and then say you're running, enter a number 4, running sum is 4.0, enter a number 5, that's 9, 3, 6. So you see, then when I enter 0, it doesn't stop.
It's still asking for a number.
Okay.
Because you're still in the while loop, yeah.
Yeah, exactly, because it's still in the while loop. So so the way I feel we should do this, I mean, we could have other ideas. I've always said everything, whatever works is always correct. Whatever works is correct. So I was thinking we should instantiate our number first outside this, outside the while loop. And first of all, the major reason why this did not work is because the number we have here is a string, and we are trying to compare it to this integer right here. So apparently what we have done earlier is very correct also. Do you understand?
No.
Okay. Right now, if we do if we do this and you say number is equals to float number, then we remove this wrapping because that's just going to be repetition. If we do that now, it should work exactly the same the way we want it to work. 4, 5, 6, put in 0, then it stops. The reason is because before we added this line, number was a string, so it was comparing 0 string to 0 integer.
Integer, okay.
Yeah, exactly. So it ends up never being equal. So that was the issue we had right there. So another way I feel we could do this also without actually doing a break is to first of all instantiate number outside of the loop, and we say, well, that's probably going to be a more verbose way of doing it. This looks like a more compact way. This way we've done. So if we instantiate it outside here, and we say number is equals to float number. Sorry?
No, go on.
Okay, number is equals to float number. And then we move this to the bottom. Sorry, we move this to the bottom of the while loop block. Then we replace this with while number is not equal to 0.
0.
Continue. Then we remove this our block. Do you get it? Okay. So if we do this way, once it gets to this level, we already have number defined outside this while block. So that means every value we collect right here replaces what we have here, and then this while loop has to check that again. Yeah. Exactly. So if we run this program also, okay, I think we have an issue right here. So this should be first, second. Okay, so 5, 4, 3, then we'll put 0, the program stops. Do you understand now? I mean, does anybody have any question pertaining to this? Okay, while there are no questions, well, let's just leave the way we did it together. That way seems to be more compact and we wrote less code with that.
But that what you just did, I think, was one of the things that Chris was talking about in the lecture, that it's a good idea to instantiate or basically define the variable before the loop.
Exactly.
That's what he always did. He initiates the variable for the loop, and then he jumps into the loop after that.
Exactly. So, but then I'm just trying to leave us a way which we treated together. I mean, my way is never my own way of coding is never the best, but I mean, this is a collective effort, and we're able to get it to work. You understand? And then also coupled with the fact that they're not making use of this number outside this loop. So this is just a very trivial problem. It was some other bigger problem where we had to use this number after this area. and we had to use it and say, okay, print number plus something, you understand, and we have to instantiate it outside for it to work. You understand?
Yeah.
So, okay. So let's go to the third problem. I think we have about 5 minutes more. I hope we can get this done. So this seems like, okay, let me summarize this problem. Let me summarize this problem. So what this problem basically does is to collect a number from you and ask you number to count to. Okay, you input 17, then the computer starts counting from 1 to 17. And then the condition there of printing is that if the number is divisible by 3, you print fizz. If the number is divisible by 5, you print buzz. Do you understand now?
Yeah.
Okay, so let's just go quickly here and then say, let's just put in passing, and then let's just describe a function to help us print the right statement based on the number we collect. So let's just say, let's call that function print value or something. I mean, I can't think of anything right now. So what does this function do? This function collects a number, which is the value the user enters. Sorry, that's not the value the user enters. The value the user enters is the number which we want to count up to. So what this print value collects is each of those numbers between 1 and 8. So if we input 17, this value is going to be collecting 1, 2, 3, 4, 5, 6, 7. Then once you input 1, it checks, is 1 divisible by 3? No. Is it divisible by 5? No. Then you print 1. Check 2. Is it divisible by 3? Is it divisible by 5? No. No. Print 2. Then checks 3. Divisible by 3? Yes. Print fizz. Then it goes on and on and on and on that way. So it takes in number and then checks. Do you have an idea how to check this if the number is divisible by 3?
You could try
Modular
Reminder we can use.
number modulus 3.
Okay. So if we can do, if number modulo 3
Equals
to 0, right? 0
equals to 0, yeah.
equals 0.
So let's say, let's just put a comment. Number is divisible by 3. Now if it's divisible by 3, what do you want to do? We want to print fizz.
Right?
Yeah, fizz. Then we also check again in the next line if it's divisible by 5. And we say if number modulo 5 is equals to 0, then we say print buzz. Then if it's not divisible by anything, we want to print the number itself. So what we want to do right here is to use an if-else statement for the 3 of the conditions. So if it is divisible by 3, print 0. L if is divisible by 5, divisible, that's equals to print buzz. Then else, this is like the fallback of the whole condition checking. Like if none of those condition holds, then you print the number. Yeah, we just print the number. So what right now we are going to be doing in this our main loop, we are going to be collecting number count. Let's call it count and say input, enter.
Don't we have to write print stranger? Print.
I don't understand you. Oh, okay, this right?
In Alpros, yeah.
Yeah, we could just do it directly because we don't have any string we are joining it with. So if we are printing,
we're gonna add it up or something.
Sorry.
Like we're not adding up with any other string, so we can
exactly. So we can just print. If it's a float, we can just print a float. If it's just a single value. If it's an integer, we could print an integer. If it's just a single value. But when you need to add it to a string, maybe in this case we want to say the number is number. Then that means you have to convert number into a string for us to be able to join it to a string. You understand? So it's about making those data types uniform, those variables. So if we are using the float, we have to make the other value also a float, a string. We have to make the other value a string. But once